Assalamu alaikum everyone. I hope all of you are doing well. So this is another activity for our interactive notebook, and the topic is transformation of 2D shapes. Okay, so we have already learned in our class that a transformation can happen in 2D shapes in four types. So three of the types are called isometric or rigid, which means after we transform the shape, the position changes, but the shape of the original shape of that shape remains the same. The size does not change. And the last one is enlargement, which is basically not an isometric or rigid transformation, because after enlarging a given object, the size of the shape changes. Okay, so let's start with it. First, you need to make this cut out. How do you make it? You take a piece of paper, then in this part you write transformation, you dot lines through it, and then through the dotted lines you fold this page like this. You fold this page like this, and then you make three sections here. The first section is for translation, the second section is for reflection, and the third section is for rotation. So, and now after making the section, you will cut these sections to the end of this dotted lines. So cut this one and this one. So now if you flip it, it looks something like this. Okay, now next step is what will be on the back of this page. So in translation, at the back of this page we will have some information given here, the definition and the steps to translate a given shape and all. So I'm reading it out what I have written in here, so please listen to it very carefully. So number one is, it is an isometric or rigid transformation. Number two, the given object is translated or moved along the x and y axis. Step number three, which are actually the steps, just add the given coordinates with the coordinates of the given object. So this is what I have written at the back of it, and now what you see is when I flip it open, it has the information. And in this section, again in this section, I have created three boxes here aligned with these lines. So when you flip it open, there is a question regarding translation, and then I have pasted graph papers to solve the questions in the interactive notebook. All of this should be pasted in your interactive notebook, and I have used white papers here. You can use colored papers, or if you're using white papers, make it colorful to look it vibrant and more creative. Show your creativity as much as you can. Okay, now if you flip it open, I've written this already. Now there is a question. Okay, so the question says, translate the given object by 1 2 and minus 3 minus 2. So this is basically the question. If you're given an object, you need to translate it, and the coordinates will be given. Sometimes it will be given like this, 1 2 or minus 3 2, or sometimes it can be given like this. See, this is a coordinate, right? 1 2. So the first number belongs to x-axis, the second number belongs to y-axis. So instead of saying 1 2, I could have said move the object 1 place to the right and 2 place to the up, because 1 is positive, 2 is positive. So in the x direction we go right, in the y direction, if it is positive, we go up. Same way, minus 3 minus 2 means I could have said it like this: move the object 3 places to the left and 2 places down, because if I'm going to the negative x, I'm going left. If I'm going to the negative y, I'm going down. Okay, now how you actually solve it. If it's difficult for you to see this graph here, let me make it clear to you. Okay, so if we are using this standard graph paper, the first thing you need to be very careful about is taking the units. It means how many square boxes are you actually taking for each unit. Unit means these values here, 1, 2, minus 3, to the values of x and y here. So for each unit, you need to determine how many numbers of square boxes you are taking. So if you look very closely, you see there are many small boxes. If you count this red lines here, in between these two lines, there are actually 5 square boxes. So if you look in this number line, if you look very closely, 1, 2, 3, 4, 5, 6 in the x-axis and the y-axis, the difference is actually 1, 2 square boxes. So for each unit of x and y-axis, I'm taking 2 square boxes for each unit of x and y-axis. See, 2 units for x, 2 units for y. For the rest of it, I have done the similar thing. For the reflection part and for the rotation part, I have taken 2 square boxes as 1 unit. So in your exam or in your graph copy, it is up to you how many number of boxes you want to take for each unit. It depends on you, depending on the size of the graph paper, depending on the shapes that you're given. So it is up to you. But don't take 1 square boxes for your 1 unit, because then it will be very congested to write the numbers here. Even you can take more square boxes. As I'm using a small square paper, so I'm taking 2 square boxes. If you're using a big big graph paper, you can take more boxes as 1 unit. Okay, so let's do it now. And use your laptop for a better view, and use your headphones for a better audio. Okay, so this object is given, it's a square. See, the coordinates are 1, 1, 3, 1, 1, 3 and 3, 3. Now the question asked is, I need to translate this shape by 1, 2 and then by minus 3, 2. So first let's translate this shape by 1, 2. So what do I do is, with the coordinates of the object, I add this thing. So let us write down the coordinates first of the object. Object coordinates are 1, 1, 3, 1, 3, 3, and this one is 1, 3. Now if I want to translate this object by this, I just need to add this coordinate with all of the coordinates here. So just add it now. So translating by 1, 2 is actually adding this thing up. So 1, 2 means this one, which is actually the value for the x, I'll add this one with all the x values of these coordinates, and this second one too is for the value of y, so I'll add the value of this y with all the y values of these coordinates. So add this one, so add 1 to each of these coordinates. So 1 plus 1 comma, and then the y was 1 and the y here has to be added is 2. Next, 3 plus 1, 1 plus 2. Third one, 3 plus 1, 3 plus 2. Fourth one, 1 plus 1, 3 plus 2. Now if I add them all up, 1 plus 1, 2, 3, 4, 3, 4, 5, and the last one is 2, 5. Okay. So I have my new coordinates of the image of this object. So let's just plot it in the graph paper. So 2, 3, 2 and 3. This is the first point. 4, 3. If I go to 4 and then go to 3, this is my second point. Then 4, 5. If I go to 4, sorry, 2 3, and then 4 3, and then sorry, I made a mistake here, I guess. This one was 3 1, this one was 3 3, this one was 1 3. Okay, fine. So I'm adding 3 plus 1 here, so this is 4 5, so 4 5, so I'm going 4 4 5. Yeah, sorry for the delay. So the fourth one is 4 5, so I'm going here. This is the x-axis is 4 and y-axis is 5, so at the very top of it this is 5. So this is my first point, this is my second point, and this is my third point. Now the fourth one is 2 5, so this is 2 and the top of it is 5. So just now connect the lines, this one was the point, connect, and then connect. So this is the OB stands for object, and suppose IMG stands for image. So this is the first image for this object here. Okay, so for the rest of it, for the second one, try it by yourself. Now, the second one is reflection. So, in this cutout, when you fold it open, what you need to write here is, I'm reading you out, so listen to it very carefully. So number 1, it says, it is an isometric or rigid transformation. Number 2, the given object is reflected along a given mirror line. And now the steps. If the mirror line is along the x-axis, we count the vertical distance, and if the mirror line is along y-axis, we count the horizontal distance. So first write this down, and then I'm going to explain it to you. So now when you open this thing up, you have a question in here which says reflect the object along the line x equals to 3 and y equals to 1. So if you remember from the class, when in a equation of a straight line, if we have the value of only one coordinate, so we always end up having a vertical or a horizontal line. And in the case where x equals to 3, which is actually the horizontal axis, but when we have the equation x equals to 3, the line is actually the opposite, vertical. And same way in y. So when y equals to -1, so when we have the value of only y here, and y actually represents the y-axis actually represents the vertical line, but when we have the equation y equals to -1, the line will actually be a horizontal line. So let's see. So let's see, the line of reflections are given, but sometimes the line of reflection may not be given in the question paper. You have to draw the line of reflection. So how do we do it? Let's do it first. First one, x equals to 3. So the value of x equals to 3, and remember, when we only have the value of only one coordinate in an equation. So if x equals to 3, it will be the opposite, the line will be vertical. So x equals to 3, so just draw a vertical line over 3, and y equals to 1. Y equals to -1. So -1, where y equals to -1, this point here is -1. So as we have the value of only y here, so it will actually be a horizontal line, opposite of y-axis. Okay, so just draw a straight line over where y equals to -1. So this is my one line of reflection, and this one is my another line of reflection. So this line of reflection actually is x equals to 3, and this line of reflection is y equals to -1. Now let us reflect the shape. So in order to reflect a shape, when we are reflecting a shape across a vertical line, we actually calculate the distance of the x-axis. So I have 3 points here, I have 3 coordinates here. As it is a triangle, I have 3 coordinates here, so I'll calculate the horizontal distance. So from this mirror line to this point, the distance is 1, 2, 1 and 2. 2 distance is x equals to plus 2. So from this mirror line, the image of this point will be exactly the same distance. So 1 and 2. This is the first image of this point. So now next, this point here, this also has a distance of 1 and 2. So the image of this point will also be drawn exactly 2 places to the right from the middle line. So from the middle line, 1 and 2. And if you look very closely, this point here is actually on the mirror line. So whenever we are reflecting or rotating a shape which is actually on the mirror line or on the center of rotation, even after rotating or reflecting that shape, that point which falls under it is actually, the image of that point is actually on it too, which means this is, as this is on the mirror line, it will, the reflected image will also be on the mirror line. So this is actually the image, this is actually the point of this object, and the image of this object will also fall in here. So the example that I gave in the class, so if you touch the mirror with your finger, the image will also be touching the mirror. So it looks like the object of your finger and the image of your finger are actually touching itself. Okay, so this is the first image, this is the second image, and this is the third image. Just now just connect the points to draw the circle. So this one, connect this one, connect this one, and connect this one. So this is the object and this is the image. Now again, when we are reflecting a shape along the horizontal line, we actually calculate the distance of the vertical distance, which is actually the y-axis. So now let's calculate. So let's start off with this point here. This is the mirror line. So the distance from this point to the mirror line is 1, 2. So the object will be, the image will be 2 places further. So 1 and 2 here. Now this point here, this is actually 4 places from this mirror line. So the image will also be 4 places. So 1, 2, 3, and at the last it's 4, which is actually -5. Now this point here, this point is actually 1, 2 places from the mirror line. So the image will also be 2 places down from the mirror line. So 1 and 2. So I have got my 3 points now. Just connect the points to make the triangle. So see, this is my reflected image, and it's actually flipped, just as you stand in front of a mirror. If you're facing the mirror, the image of yourself is actually facing you. So that is how reflection is done in both the cases.